Okay, what's up guys? Mr. Fabella here. Today we're going to continue what we were doing earlier. So last time we were discussing the parts of a circle, circumference, and today we're going to be continuing that trend and going over the area of a circle. We're going to start off with not by doing some practice problems or anything, but just actually figuring out where the formula of a circle even comes from, because a lot of times you can be confused by the circumference and area, and it's kind of hard to differentiate between the two if you don't know how they're derived, or at least it helps by knowing how they're derived. So let's take a look at this circle right here. It is cut up into 8 little slices, so that's going to be part of it. Usually if we're in the classroom, I'd have you guys cut these up and kind of rearrange them, but we're not, so I'm going to kind of show it to you this way through here. So let's take a look at this, and let's say I take one semicircle each. So again, semicircle is exactly half of a circle. I split it up into 2 pieces. Okay, so now you know that that's the radius, right? So from last lesson, you know that from the center to the circle, that's called the radius. All right, so you have that, and then you also recall that the measurement around a circle is called the circumference. And we showed from calculating pi that the circumference equals pi times the diameter. Okay, so if the entire circle is pi times the diameter, what do you think half the circle is? You said pi times radius. That's exactly right, because radius is half the diameter. So if you're getting half the circumference, it makes sense that it would be pi times the radius. Okay, so that's just around the semicircle, not counting the part inside. We're just talking about the semicircle. Let's pretend that there are little hinges here, here, and here. Okay, and then you can kind of unfold it that way. You get like these little pizza slices like that, or like it looks like little decorations that you hang up on someone's birthday or something, little pennants. Okay, we do that. And then let's do the same thing for the bottom half, right? And then let's stick them like teeth. Okay, so then you have that little figure there. All right, so let's label these again. So we labeled it before when it's part of the circle, right? We said that this part right here was the radius. That goes over there. That's still the radius. And what about the top part on the top? That was half of the circle. Well, that's pi times the radius. Okay, so, but that's like a really weird looking shape, right? So it doesn't really look like anything. So let's do the same thing, but let's cut up the area of the circle even more. So we'll cut it up into 16 slices, so twice as much, right? So we'll cut it up, do the same thing. Take 2 halves. This is still the radius, right? The whole way around the circle is still the circumference, and so circumference is pi times the diameter, so half the circumference is pi times radius. And then we'll do the same exact thing, all right? We'll take the teeth, pretend that these are little hinges, open them up, do the same for the bottom, make them go together. All right, so then you have something that's getting closer to the figure that we're aiming for. Can you guess what it is? Radius is here, and on top, it's still pi times the radius. They look like kind of different, but they're still the same. Okay, so what do you think would happen if you took very, very tiny, tiny slices, even like infinitesimally small slices? The shape that you would actually get would actually be a rectangle, right? Like there would be very, very tiny slices. And then, but the parts of the rectangle would still be the same as the 2 examples that I just gave. So the width would still be the radius. It's still the side, it's still the same. And then the top part, that would still be pi times radius. If you think about how do you find the area of a rectangle, it's length times width. Well, that means radius times pi times radius. If you rearrange that, pi times radius radius, or radius times radius is radius squared. So that's how we get the area of a circle is the pi times radius squared. Okay, and we could not have derived that this way without knowing that the area, we could have not derived the area of a circle without knowing that the circumference was pi times the diameter. Which kind of makes sense, because if you think about it, if you have a circle, the two easiest things to measure are the diameter, just tape measure all the way across, and the circumference, tape measure all the way around. It's very hard to find the area of a circle, because if you remember, area is in units squared. It's very hard to count little squares inside these circles. So that's how we get the area of a circle is pi times the radius squared. Okay, off to some examples. Here are some easy ones first, and then we're gonna work up to kind of harder ones. So right here, it says find the area of the face of the Virginia quarter with a diameter of 24 millimeters. I'm gonna highlight that. And it says use 3.14 for pi. So if you remember, 3.14 is just an approximation of pi. Round to the nearest tenth if necessary. Okay, so first of all, I'm going to rewrite the formula for the area of a circle, which is pi times the radius squared. Okay, so I wrote out area equals pi r squared. But right here, the important thing to note is it says it's a diameter of 24 millimeters. You cannot find the area of a circle using the diameter. You have to find the radius first. So radius is 1/2 of the diameter. So the radius is 1/2 of 24. So the radius is 12. I'm not going to keep doing this each time, but just to show you that, that's what you have to think of. You have to get the radius first. So area equals pi, which it said to use 3.14 as an approximation, times the radius, which is 12 squared. Okay, so from here, this is just working everything out. Remember that you have to follow order of operations. So you cannot multiply 3.14 times 12 first. You have to do the exponents first, and then you multiply. So 3.14 stays the same. 12 squared is 144. And then you can multiply this out. And you get 452.16. But it says round to the nearest tenth if necessary. So I'm going to round that up to 0.2. And then this is area, and it's millimeters squared. Okay, there are some questions where it actually tells you to use 22/7 for pi, which it's also an approximation for pi, just like 3.14, it's an approximation. So, same thing, area equals pi r squared. It already gives us the radius of 14 centimeters, and I'm going to use this for pi. So, let's go with pi as 22/7, and the radius is 14 squared. If I really wanted to do this, I could, so right now I can't cross cancel because I have to do the exponents first. But what if I did 22/7 times 14 times 14? Because that's the same thing as 14 squared, right? So now there are no exponents. I can cross cancel this 7 and this 14. This is 1 and 2. And then I can just multiply across. I have a denominator of 1, so I just go 22 times 2 times 14. And that's 616 centimeters squared. Okay, so earlier I said we would talk about the area of a semicircle. It's just half of a circle, so not part of a circle. So you can't have a circle and say, oh yeah, that's a semicircle, that top part, or this part is a semicircle. Semicircle is exactly half of a circle. Okay, so it's just 1/2 pi r squared. All right, so right here this is 16. Since it has this red line going all the way through there, that means that the diameter is 16, right? So the diameter equals 16. I need to find out the radius, so the radius would be 8 because it's half of 16. So area equals pi r squared. It says use 3.14 for pi. Okay, so I'm going to go 3.14 times the radius, which is 8 squared. So 3.14 times 64. And then for all of these, you can use your calculator. So that's going to be 200.96. Okay, so that's the area of the entire circle, but then recall over here, it said find the area of the semicircle. So the semicircle is actually 1/2 of all this. Okay, so all I need to do is take 200.96 times 1/2, or just divide by 2. And I get 100.48. But again, it said round to nearest tenth, so that would be 100.5. And then we have inches squared. Basketball court, there's a semicircle above the free throw line that has a radius of 3 feet. Sorry, it has a radius of 6 feet. Find the area of the semicircle. Use 3.14 for pi. So radius of 6 feet, so we don't have to change it from diameter. 3.14 for pi. If you're not sure what it's talking about, above the free throw line, so it's, you know, above the key. I'll just throw a picture up there right now so you can visualize it. So it's asking for this part right here. Area equals pi times radius squared, and let's make sure you remember that we're talking about the semicircle. So it's 1/2. So 1/2, 3.14 is there. If it feels weird for you to do that, you could say 0.5, since you're mixing decimals and fractions, and then times the radius squared. The radius is 6 squared. All right, so again, follow order of operations. 1/2 times 3.14 times 36, and just multiply all that out. 56.5. Okay, so that would be 56.52. Again, you can use a calculator. That's not really the purpose of this exercise. It's that you actually know how to use the formula and know when to use it. Okay, so we're not done yet because it says round to nearest tenth, and I'll just get rid of that too, and that is feet squared. 56.5 square feet, about. All right, so we have a example problem here from Alex. It says a ring-shaped region is shown below. The inner radius is 9 feet, that's right here, and its outer radius is 13 feet. All right, find the area of the shaded region. So this is like if you find a ring or a washer, find the area of that. All right, so let's think about what we're gonna do. So it has the inner and the outer radius. What we wanna do is find the area of this big circle, right? And it'll give us everything, right? But we don't want everything, so we have to find the area. So we have to find the area of this smaller circle and then subtract it out. Okay, so that's our plan. Let's stick to it. So I'll write it up here. Area of the outer circle minus the area of the inner circle. Okay, so let's see. Area of the outer circle is equal to 3.14 times the radius, which is 13 squared. Okay, so you know what? Actually, I'm looking at this. I'm actually going to not put in 3.14 just yet, because this is like kind of what you do in later grades. You don't even multiply pi out yet. So here, I'm just going to leave this as pi times 13 squared. Okay, so that's 169 pi. I'm not even going to multiply that out. So actually, I can leave the equal sign there. All right, so area of the inner circle is pi times 9 squared. 9 squared is 81. 81 pi. Okay, so interesting part here, I'm going to fill this out. Area of the outer is 169 pi minus area of the inner is 81 pi. So each one of these terms has a pi in it. That's like a variable in a way, in that you can combine like terms and you can subtract, so that you can subtract 169 minus 81. So that's actually 88. 169 minus 81 is 88, and then 88 pi. So what that did is it kind of saved me time. It's actually equal to 88 pi. So now I can multiply it out. So 88 times 3.14, that's 276.32. It says do not round your answer. And this is square feet. So that's actually going to be, a lot of times you would just leave it in terms of pi, but if you actually want a measurement, if you're going to go out and buy material, you're going to want to do that there. But what I just did is I just kind of saved time. Instead of multiplying 3.14 out twice, I just had to do it once. And then also it let me avoid getting two fractions here and here and having to subtract two fractions. I did say you can use the calculator, but it still saves time punching it in. All right, so let's go for the last example here. A rectangle is placed around a semicircle as shown below. The length of the rectangle is 4 yards. Find the area of the shaded region. So I just want the area of the shaded region and use 3.14 for pi. Okay, so let's make a plan here. I want the area of the shaded region is going to be equal to, we have a rectangle here, right? So I want the area of the rectangle minus the area of the semicircle. Let's go with the area of the rectangle first. That one looks a little easier. So let's label these parts here. It says the length of the rectangle is 4 yards, find the area of the shaded region. So you might be thinking, okay, this is 4 yards here, but what's that supposed to be? Okay, so this is a semicircle, right? That means this right here is the diameter. Okay, half of the diameter is the radius. That means from the center over here. Well, if that's the radius is from the center to the circle. That means this is also the radius from there to there. So if the diameter is 4 yards, that means the radius has to be half of that, which is 2 yards. If that's 2 yards, that means this is also 2 yards. All right, so that's a little tricky there. So area of the rectangle, I'm just going to put it down here as length times width, so 2 times 4. Okay, minus area of the semicircle. Okay, I'm going to erase some of this stuff here. Actually, no, I don't need to erase anything, right? Because we already said that this was 2 yards. Everything, there's a lot of 2 yards, so this radius here is 2 yards. So area of the semicircle is 1/2 times pi times the radius, which is 2 squared. All right, so everything's all in one spot. So we have, this is 8 minus, and then we have to make sure we're going to multiply 2 times 2 first. That's 4. Half of 4 is 2, so 2 times pi is 3.14. Okay, so then we just work this out. 6. So this is going to be 8 minus 6.28, and then you subtract that. 8 minus 6.28 is 1.72. I wanted to make sure. All right. 8 minus 6.2 is 1.72. Let's see. It says, do not round your answer. Correct units. This is area. So this is in yards squared. All right. Okay, so hopefully this was helpful on finding the area of circles and semicircles, and I'll see you guys next time.